2020 Exam 2, Question 5, Data Analysis. Okay, so for this one, and they're a little bit fussy in the answers, you had to draw the graph of the line of the least squares on the scatter plot above, which is actually over here because I moved the question. And in the answers, they recommend that you actually calculate the 2 points. So I just went, well, I'll get my 60 and my 130 endpoints. So I did that. And I got 1.104. Now, that's going to be 1.11, 1.12, 1.13, 1.14. So it's going to be starting about there, about halfway between 1.10 and 1.11, roughly. And then this is why you need little rulers, because you have to follow across. This is very close to 1. So I'm going to, you've got to follow across like that. So it's going to be about that point there, isn't it? So there'll be a point there, and then you should use a ruler to join them up. And you needed to go edge to edge. So important points to note. You needed to actually calculate the values, not just eyeball it. They were quite fussy. And you needed to actually draw the line with a ruler, and you needed to go edge to edge. I think they were being very fussy. But there you go, something like that would get you the mark. You thought I was going to try and draw it, but I just used the draw with a straight line function. I don't have a ruler. Okay, so we've got to use the equation of the least squares regression line again, so third time, but this time they actually wanted to give the answer. So we're going to be using that equation for predicting 65. And we've got to make sure we round the answer to 2 decimal places. So there's the calculator again, got this number, 2 decimal places, 1.10, because there's the 2 decimal places. 9 looks at the 6 and goes, oh, got to be 10. How many times do people get this wrong? So please, don't be that person who doesn't know that round. It is 1.10. It didn't say anything about units, but what the heck, I'll put them in there. And capital L for litre, because that's the correct way to do it. Then the next one is when using the equation of the least squares line to make the prediction in part B, lovely, 1.10, are you extrapolating or interpolating? So 65 is here, and if you come up like, yeah, it looks clearly like there's no data points, it's not between data points. So if you're here or here or here, you're interpolating. This is quite clearly extrapolating. There's no data to the left and right. It's only data to the right. So it is extrapolating. Okay, so now we need to interpret the slope of the slope. So that's this number down here. In terms of body density and waist measurement. Here's what they put in as the acceptable answers. Now, first of all, this is a negative, so you use the word decrease. So don't use the word decrease and then stick a negative in here. That's technically a double negative. So say decrease with the number. If it was a positive number, increase. All right, so that's the first thing to note. The next thing to note, you needed to say for each 1 centimeter or each centimeter, like in these ones. And then you had to have a third point, which is the idea of the increase. So we've got increase here, or the word additional, and again, increase. So most people fluffed up because they just said each increase. They wouldn't accept that. So you've got a decreasing word, and that's the one that changes. That's the positive / negative choice. All right. So in this case, because it was negative, we say decrease. If it was positive, we'd say increase. You've got to make sure you say for each and then give it the unit. We need the unit, that centimeter in there. And then you've got to say increase. It'll always be increase there. So that doesn't change. No change here. Okay, because the change is happening with for the gradient is happening in that first yellow highlighted word. Okay, so make sure you're getting that all right and don't do a double negative. So you don't, that's just the number. Don't make it positive or negative, just leave it as the plain old number. Okay, so they're giving us some values here. They're saying that the waist measurement of 122 centimeters gives a density of 0.995. And we need to show that when this least squares line is fitted to this couplet, the residual will be, when rounded to 2 decimal places, minus 0.02. So it's quite a nice question in terms of, you could tells you the answer. You've got to show that that is the answer. So don't just write the answer. So what is the residual equal? Residual, and this actually I think is on one of the few things on the formula sheet, equals actual minus predicted. Don't know if they wanted the whole formula on that. So that's going to equal 0.995 minus, and we'll put the brackets, and we're using the formula, that formula down there, 1.195 minus 0.001512 times 122. And what does that equal? Well, you get your calculator out for that. And so you get 0.995 minus 1.010536. And what does that equal? You get that. So that's going to be negative 0.015538, which approximately equals minus 0.02, which is what they wanted. And I guess to get the full marks for that. Right, well, this question just keeps on going, doesn't it? So the coefficient of determination, that is r squared, is this number, 0.6783. Now we need the correlation coefficient, they're given as r, so you can tell that there's not going to be confusing r and r squared. And you need to round your answer to 3 decimal places. Don't be that person who can't round. And so, classic trick in this, you square root it. That's how you do it, just do hat 0.5. You should know that by now. And you get this value, and so you go 3 decimal places. I go 1, 2, 3. 3 looks at the 5, so it goes up. 0 to 4, stay on the floor. 5 to 9, climb the vine. And you go 0.824. But no, remember the slope is negative, therefore the r must be negative. Okay, so slope and r have the same sign, and you can see that you got that lovely, very nice straight line showing the negative slope. They've done that a few times with people. Again, don't be the person who can't round, and don't be the person who falls for the trick that, you know, if you take a negative number and square it, it becomes a positive number, and the calculator won't give you that negative. It won't do that right there. It's just going to give you what they call the prime root. I don't know. So we've got a residual plot below this thing here, and if you look at it, it's quite blobby. There's no frowny face, no smiley face pattern in there, so you can say, yes, your assumption of linearity is okay, because no clear pattern. And that's what they're saying. Does it support this? Yes, because there is no clear pattern in the residual. There is no clear pattern, no clear handwriting, in the residual plot. And finally, I think that question is done.